Theorems of moment of inertia. Theorems of moment of inertia. There are two theorems regarding moment of inertia. One is parallel axis theorem, the other one is perpendicular axis theorem. There are two theorems regarding moment of inertia. One is parallel axis theorem, the other one is perpendicular axis theorem. Mathematical form of the theorems. The perpendicular axis theorem is written as Iz is equal to Ix plus Iy. Iz is equal to Ix plus Iy. The parallel axis theorem is written as I is equal to Ig plus Md square. I is equal to Ig plus Md square. In the perpendicular axis theorem, Iz indicates moment of inertia about z axis. Ix, Iy indicate moment of inertia about x axis and y axis. In the second theorem, I indicates moment of inertia about a parallel axis. Iz indicates the moment of inertia passing through the center of gravity. M is mass of the body. D is the perpendicular distance between the two axes. To understand perpendicular axis theorem, take a rectangular parallelepiped, a body of the shape rectangular parallelepiped. Imagine x-axis passing through the center and parallel to the length, y-axis passing through the center and perpendicular to the length or parallel to the breadth, and z-axis passing through the center and perpendicular to both these axes, both x-axis and y-axis. Now, moment of inertia about x-axis is Ix, about y-axis is Iy, and about z-axis is Iz. Now, the relation is Iz is equal to Ix plus Iy. Like this, we have to imagine the moments of inertia of the parallelepiped. So, the relation between the moment of inertia is given by Iz is equal to Ix plus Iy. Ix, Iy will be in the same plane. These two axes will be in the same plane, and Iz is perpendicular to the plane contained by Ix and Iy. Parallel axis theorem. To understand parallel axis theorem, let us take the line, vertical line passing through E as the axis passing through center of gravity G. The axis passing through center of gravity G. Let us consider another axis passing through O at A. Passing through O at A. EF is the axis passing through center of gravity G, and AB is the axis passing through O. Now, the mass of the entire body is capital M, and the perpendicular distance between the two axes, that is OG, is equal to D, small d. The perpendicular distance between the two parallel axes is D. Now, the relation is I is moment of inertia about AB and Ig is the moment of inertia about EF. Hence, I is equal to Ig plus Md square. This is the relation between I and Ig. So, if Ig is moment of inertia about center of gravity, then the moment of inertia about an axis parallel to it at a distance d is given by I is equal to Ig plus Md square. Proof of perpendicular axis theorem. Let us prove the perpendicular axis theorem. Let us consider a body, and P is a particle in the body. It is in the xy plane. Let us imagine xy plane is a horizontal plane and P is a particle in this plane. Then the perpendicular distance of this particle from y-axis is x, from x-axis is y, and from z-axis is r. The perpendicular distance of this particle P from x-axis is y, from y-axis is x, and from z-axis is r. We have the relation. We have the relation for moment of inertia as mr square. If m is the mass of the particle and r is the distance from the axis of rotation, perpendicular axis of rotation, then it is mr square. I is equal to mk square. M is mass, k is radius of gyration, the perpendicular distance. So here the moment of inertia about x-axis is my square, because m is mass of the particle P and y is the perpendicular distance from axis of rotation. So the moment of inertia about x-axis is Ix is equal to my square. And the total moment of inertia of the entire body about x-axis is given by sigma myi square. Sigma myi square. Then moment of inertia about y-axis is mx square, because perpendicular distance is x. This iy is equal to mx square. The total moment of inertia about y-axis is iy is equal to sigma mxi square. Sigma mxi square. The moment of inertia about z-axis is mr square. The moment of inertia about z-axis is mr square. The relation between x, y and r is r square is equal to x square plus y square. R square is equal to x square plus y square. If m is the mass of the particle, then mr square is equal to mx square plus my square. Mr square is equal to mx square plus my square. Iz is equal to sigma mri square. Iz is equal to sigma mri square. That is equal to sigma m into y square plus x square, mx square plus my square. That is equal to sigma my square plus sigma mx square. Sigma mri square is equal to sigma myi square, sigma myi square plus sigma mxi square. But sigma myi square is ix, sigma mxi square is iy, hence iz is equal to ix plus iy. Hence iz is equal to ix plus iy. Proof of parallel axis theorem. Proof of parallel axis theorem. Let us consider an irregular body. Let G be its center of gravity. EF is an axis passing through center of gravity G. AB is an axis parallel to EF at a distance D. AB is an axis parallel to EF at a perpendicular distance D. The perpendicular distance is OG. Now let us consider a particle P. Let us consider a particle of mass m, particle P of mass m. Its distance from center of gravity is B, and its distance from the axis AB, perpendicular distance from the axis AB is r, small r. So OP is small r and GP is small b, and OG perpendicular distance is D. Now the moment of inertia of the body about center of gravity is, say, Ig. The moment of inertia of the particle P is mb square about the axis EF. The moment of inertia of the particle P is mb square. The moment of inertia of the entire body about center of gravity Ig is equal to sigma mb square. Sigma mb square. The moment of inertia of the particle about the axis AB is mr square. Mr square is moment of inertia of the particle P about the axis AB, and the moment of inertia of the entire body about the axis AB is I is equal to sigma mr square. I is equal to sigma mr square. Produce OG and drop the perpendicular from P. Let it be PQ. PQ is the perpendicular dropped onto OG produced. Now consider the right angle triangle OPQ. Consider the right angle triangle OPQ. In this right angle triangle, OP square is equal to R square. R square is equal to OP square. OP square is equal to OQ square plus PQ square. OP square is equal to OQ square plus PQ square. But OQ is equal to OG plus GQ. OG plus GQ. OG is small d. Let us suppose GQ is equal to small a. GQ is equal to small a. Then OP square becomes equal to d plus a whole square plus QP square. D plus a whole square plus QP square. That is equal to d square plus 2da plus a square plus QP square. that is equal to d square plus 2dA plus a square plus qp square. In this relation, a square plus pq square, a square plus pq square becomes equal to gp square or b square, gp square or b square. Hence, OP square is equal to, or R square is equal to d square plus 2dA plus b square, d square plus 2dA plus b square. If we multiply both sides, left hand side and right hand side, with small m, we get mr square is equal to md square plus m into 2dA plus mb square. mr square is equal to md square plus m into 2dA plus mb square. The moment of inertia about the axis AB, I is equal to sigma mr square. Sigma mr square, that is equal to sigma m into d square plus b square plus 2dA. Sigma md square plus mb square plus 2mdA. In this relation, sigma m into d square becomes equal to total mass capital M into d square. Sigma m is the total mass of the system or the body. So, I is equal to capital M into d square. Sigma md square is capital MD square, and sigma mb square is Ig, moment of inertia about center of gravity. So, md square plus Ig plus 2d into sigma ma. Sigma m into 2dA becomes equal to 2d into sigma ma. 2d into sigma ma. In this relation, sigma ma becomes equal to 0. Sigma ma becomes equal to 0 because sigma mg into a is 0. Sigma mga is 0. Mg is weight of the particle P. Mg is weight of the particle P. Mg into a is moment of the particle P. Moment of the particle P, and sigma mga is the total momentum of the system about center of gravity. The total momentum of a system about center of gravity will be 0. The total momentum of all the particles about center of gravity will be equal to 0. Hence, sigma ma becomes equal to 0. Therefore, I becomes equal to md square plus Ig. md square plus Ig. This is the relation for parallel axis theorem.